All right, we've talked a lot about light, and I want to talk now about materials, which are kind of the other side of light. Light illuminates materials and makes them look realistic. Let me get a share screen going. So um, we're going to do this using the standard shader. The standard shader uh, is relatively new. It was introduced in Unity 5, and we're, of course, in Unity 2.17, 2.18, 2.19, 2.20. But the standard shader is still pretty much the same throughout all of these. It replaces a lot of the legacy shaders, some of which are still available in Unity and still work, but the standard shader is much better. The standard shader is an example of physically based shading, PBS, that simulates how materials and light work in a physically realistic way. It models how light behaves in reality, um, and whereas the old legacy shaders were kind of ad hoc models that worked but were hacks. Um, uh, the physically based shader conserves energy, which means that objects don't reflect more light than they receive. It includes Fresnel reflections, grazing angles reflect more, and also how surfaces occlude themselves. It's designed primarily for hard materials or architectural materials, things like stone, glass, ceramics, but it'll do skin, hair, and cloth and other things. The Viking world is a good example of a lot of different materials. Um, uh, I'll leave you to find that on the asset store. So as I mentioned, PBS does energy conservation. So as you make a material more specular, which is mean more of the light comes back in the shiny spot, that that means that the rest of the surface becomes less and less diffuse, less bright. So if you make a material shinier, it will get darker where the shiny spot isn't. It also has access to high dynamic range, HDR, which lets you render colors that are outside the usual 0 to 1 range. We'll see examples of that later. Um, uh, I'm not going to worry too much about the context here, but in an initial scene where we start off with nothing but the skybox, the light, uh, and we add an object to it with the default material, we'll immediately see it properly lit. Uh, there's a kind of subtle brownness on the bottom because it's picking up ambient light from the bottom half of our default skybox, and it's kind of bluish on the top because it's picking up light from the top half of our skybox. This makes life very, very easy. We talked about skyboxes, the baked or procedural ones, and how that contributes to the uh, uh, ambient light. So we create materials. We do it from a pull down. We can create a material from a pull down here, create a material, and we'll get a brand new material without having to do much. It comes up with kind of an empty material. Um, and um, we'll be working within the material editor. The material editor has a lot of different features. It's very efficient in that if you don't use one of the features, it actually cuts the code out and doesn't include it. So while every standard shader has, say, a normal map If you don't provide one and don't ask for one, it doesn't spend any resources in invoking it. So here's the material editor. We've got the main maps, the albedo, the specular, the normal map, the height map, occlusion, emission, a detail mask, and secondary maps. The detail mask and the secondary map, or the tiling for the main maps is here. And then there's a separate option for tiling the secondary maps. I'll show you what that's used for in a little bit. We have the shader and the rendering mode. Various values can be set with maps or color pickers, and we generally use UV mapping. There also are these masks that let you have different material properties across the same mesh, and I'll show you how that's done in a second. You can create these different textures all on a single mesh. Where the resolution of the texture is greater than the polygon topography. For instance, you can work on a quad that only has 4 points, 4 nodes, but will have texture across that quad that reflects a lot of structure in the surface. Textures are generated either in external programs like Photoshop, or if you're working in Blender or Maya or one of these 3D, they also have the capability of exporting the various textures that you'll use. Texture maps should not include lighting, so there shouldn't be shadows in your texture maps, because the shadows and the specular highlights and all that will be added by the shader. And so you don't really want shadows in your texture maps. There are 2 standard workflows. There's the standard and there's the standard specular, and they differ slightly. With the standard setup, we have this parameter called metallic that is how metallic the material is. A value of 0 means the material is kind of chalk-like with no reflectivity. And if we crank the metallic all the way up to 1, it becomes extremely reflective and reflects the skybox or whatever reflection probes you might have provided. The color of our object is reflected by the albedo. And in metallic, the albedo color also controls the specular highlight, the shiny spot, and the more metallic it is, the more light will be reflected as specular. On the other hand, the specular setup has a separate parameter for the specular color. And so this means you can actually have something else, that some other color for the shiny spot that's not necessarily dictated by the material itself, but is dictated by the color that you specify. So there's a great deal of flexibility. This is a TMO, too many options. You can make things look basically the same. On one hand here we have the metallic, or the standard workflow, and on the other we have the specular. And because we've specified a specular color here, we're getting pretty much the same behavior in the 2 images. So both paths can lead to the same outcome. I'll show you examples of those later. Depending which of the pathways you choose, metallic workflow or specular workflow, you'll see different parameters. Here's the metallic So we have a metallic, which has a slider that goes from 0 to 1. We can also put a mask in here that will determine uh, uh, what the metallicness of the material is. And the mask should be a black and white image or a grayscale image. And the whiter it is, the more metallic it'll be. The blacker it is, the less metallic it'll be, 0 to 1. Same with smoothness. If you put a texture into the metallic, both the metallic and the smoothness are controlled by different channels of that texture. I'll show you that in a minute. One thing we have to choose is the rendering mode. This is a choice between opaque, which is kind of the default. Normal solid objects have no transparent areas. And then we have a couple of different transparent modes. One is the cutout, which creates hard edges between the opaque and transparent areas. You sort of set an alpha threshold above which things are opaque and below which things are transparent. And this is useful for making materials such as leaves or cloths or glass with holes or whatever. Transparent is good for realistic transparent materials such as plastic or glass. In this mode, the material is transparent based on the texture's alpha channel. But you'll still see specular reflections and lighting highlights as you would expect with a piece of glass that still has shiny spots and reflections in it. There's also the fade mode, which just fades everything out. This is not suitable for a plastic glass because as you fade something out, those reflections and highlights disappear as well. Transparent here works well for this visor that has reflections of the sky and so forth on it. And for windows. The windows actually have a combination of opaque and transparent areas that are specified by the albedo values having 0 to 1 in the alpha channel that lets us make parts of our object opaque and parts transparent. A hologram, we might use the fade example to make it fade away. The cutout is used for sharp edges. We've seen this used with the grass that we painted our terrain with. The grass was an example of a cutout where we have a sharp edge between the material that we want to see and the transparency that we don't. And this is done with a black and white mask of this sort on the alpha channel. So I'm going to pause the recording here and I'll come back and talk about the specific channels in just a minute. So I'm going to stop here and I'll come back in just a minute. I'm going to stop the sharing and I'm going to halt the recording and I'll see you all in class. Bye.